Okay, so this video is trying to, in this video I'll try to explain how to solve this problem. LeetCode 105, construct binary tree from preorder and inorder traversal. So given two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of a same tree, construct it under binary tree. I hope you guys know what pre-order and in-order is. So basically I'll just give a very small example. Pre-order is basically you take the root first, then you process the left subtree and then you process the right subtree, right? And basically recursively do the same. And for in-order traversal, you take the left subtree first, process it, go to the root, and then follow it by processing the right subtree. So that's what in-order and pre-order traversals are. So here the important thing to note, that in a binary search tree, not in a binary tree. So this problem is about binary tree, not a binary search tree. But in a binary search tree, the in-order traversal is kind of sorted. But we can't say the same for the binary tree, so we can't use that. So basically, if something is sorted, then probably we can use a binary search on that particular array. The array is sorted, but obviously since for binary tree the in-order traversal is not necessarily sorted, we can't use that approach. So if you want to find an index there, we have to basically do a linear search, and we're left with no other option, right? So that was the purpose of me discussing that. And now, okay, so now how will we solve this problem, right? We have the pre-order traversal, we have the in-order traversal. So how do we solve this problem? So let me explain you my approach. So forget about the forget about the in-order traversal. We have a pre-order traversal, right? So you'll have a pre-order traversal. We'll basically take the root node first, then we'll process the left subtree, all the nodes of the left subtree, and basically print them in some order, and then process all the nodes of the right subtree and print them in some order, right? So obviously number of nodes of left subtree and right subtree won't really change. So that's another point to note. Now we have the in-order traversal, right? So basically now from this simply we can very easily find the root. Now we have the in-order traversal, right? So we can do a linear search in this in-order traversal array and figure out what the root is here. So since the in the in-order traversal left subtree is processed first, we'll find the left subtree here, and the right subtree will be just after that, right? And then from this position of this right, we can find out the number of nodes in the left subtree. Suppose this is x, and some number of nodes in the right subtree will be everything after that till the valid index, last valid index. So that will be y. So then we just take x indices here, and then that this will be the pre-order traversal of the left subtree, and then after that the y indexes, which is basically the leftover elements, leftover list of the elements will be the elements will be the array which represents the pre-order traversal of the right subtree. So we can just have two sub problems, right? Now solve this entire problem for us. We'll put this pre-order traversal and in order traversal in the next recursive sub problem. Let's call it the left recursive call, right? And then we'll put this here for the right subtree, we'll put its pre-order traversal and the in order traversal in its right recursive call, and that should solve our problem, right? That should solve our problem. That's and then when when we find a single node, then that is the subtree, that is the subtree, main subtree, and then we return that, we convert this particular value into a tree node and return this, and that's how we go in and construct. So basically at this point, so again this is about construction. So at this point we'll just construct the root node, and then its left kind of pointer of this root node will be processed by the solver of the left pre-order and the in-order traversals, and the right root node right pointer of the root node will be processed for the solver, which takes as input the pre-order and the in-order traversal of the right subtree. So I think you get the basic idea. Now with this idea, let us jump into the code and see how this idea is actually getting implemented. So okay, we have a main function build tree. We have taken the preordered size, which is basically equal to the inordered size, as in a variable called length for easy processing, right? And then obviously this helper will return us the root, and then also populate the entire tree and return the root with us, which we are expected to return. This is basically how we are returning the uh, binary tree which we have constructed, right? So let us now peep into the helper function and see what it does. And okay, so if the pre-start is greater than pre-end, that is something invalid. So return null pointer. Then our root val is obviously the pre-order start element. Then we search for the, and then if the pre-order search and the pre-order end is the same thing, so we have one value. So that will basically, so from one value, basically what we can construct a tree of only one node, right? So that is what we return here. And then our main operation starts from here. We'll basically try to figure out the root val in the in-order traversal. Obviously if it was a binary search tree, then we could do kind of a binary search here to figure out the location or the index of the root element. But since it's not the binary search tree, we have to do a linear search. We define the left and the right bounds of the kind of the array which we have obtained from the input. Initially that would be for 0 and n minus 1, right? And then we'll basically go through all of them and then try to find out where is the root val index corresponding to the root val, right? If I try to find that, and obviously this if this index is not equal to root val, that will be an error, but that's not really required at this point. We can It's not required because we always will find that because we only have valid inputs. So okay, so now once we have found the index at which we find the root val, then we construct the node of the root val, and then for the node dot left. So this is important. We basically pass the helper and then pass the pre-order and in-order sub arrays of the left subtree, and then for the right pointer, we pass into helper the the ranges of the uh, pass into helper the pre-order and the in-order sub arrays of the left subtree, sorry, of the right subtree, right? So this is what I've already explained in the whiteboard, so no surprises here. So now let us look at how this is how this all these ranges are coming to, right? So let me explain this a bit further. So now which ranges are easy? So I think I think for the in order the ranges are pretty straightforward, right? So once you find the mid, then the in start to mid minus one would be the left subtree in order, and the mid plus one to end will be the right subtree in order. So that's pretty straightforward. Now once we have this, right, in start and mid minus one. So now how many elements are there? The elements would be mid minus one minus in start plus one. That would be the number of elements, right? So the same elements that we want, but starting from the pre-start plus one, right? So what would be it will be pre-start plus one plus mid minus one minus in start, right? So that would be, so basically, so what is happening here is, let me go back. So there is something called mid minus one, sorry, something called in start, and then there is mid minus one, and then we have pre-start plus one. This is the index from which is the pre-order of the left subtree starts from. There is no issues here, and there is no issues here. So now what is the ending index of the pre-order subtree? That is the thing that we need to calculate. That would be, so basically what we want is suppose it was 5 and it was 2, right? And then we want to and suppose this is 1. We want an end index which will give us sorry, this will be 2 in fact, and this will be 5. This will be 2, this will be 5. We want an index which will give us like 4 elements, right? Suppose this starts at 1. So what should we do? We should do a 5 minus 2. This will be our end index because this was 1. Why? Because you can see, right, we want four values. So if our end index is 4, from 1 to 4 we have 4 values, so this works, right? Okay, so that is what we have done here. So if it is so we need to just add 5 the difference between this ending range and the starting range of the in order subtree here. So our ending range would become pre start, right, plus 1, and then plus mid minus 1 minus in start. So that is what we have here. If you look at that, this is pre start plus 1 plus mid minus 1 minus in start. So that is what you have here, right? Pre start plus 1 plus mid minus 1 minus in start. So that is what you have here. So that is explained. And similarly, now we'll do the same thing for the right preorder subtree, right? How will do that? So for the right subtree, it will start from mid plus 1. Let me choose another color. It will start for the in-order subarray. It will start from mid plus 1 to int end. Okay, in order end. So basically, what we need to add in the last range is uh, int end, right, minus mid minus 1. That we need to this we need to add, and the to the start of the right preorder traversal start to get the end of the right preorder traversal subarray, right? So I think the right start would start at where would it start at? It would start exactly where the other one ended. So let me go here. Okay, pre-end. That this should be so. Okay, wherever this is a bit complex. So let me do this. So this ended here. Okay. So let me cancel this, and this will be plus 1. This is where our next index begins. So should be pre-start plus mid minus in start, right? Plus mid minus in start, and then plus 1, and then this 1 and 1 would cancel, right? And then mid would also, I think, cancel. We'll have this value. Are we getting this value? Pre-start minus 1 plus mid minus 1. So this is pre-end. Pre-start minus 1 plus mid minus 1 minus in start. Let me come back on this. This comes out to be PS plus int end minus int start, right? So this is nothing but p end, because what is the end of the preorder matrix? So the preorder left subarray is this and right subarray. So the end would be the end, right? End of this array. So there is nothing to kind of think about. So this should be the end. This is already we have. This is one of the inputs that we get directly. We use that, right? So our start would be this, right? Pre-start plus 1 plus mid minus 1 minus in start in order start plus 1, and then our end will be just pre-end end of the preorder traversal that we already get as input, right? So let us look into it. So our end is pre-end, and then start is pre-start plus 1 plus mid minus 1 minus in start plus 1, which is I mentioned here. Okay. So yeah, this values get a bit too long, but yeah, but it's not that difficult to understand, and with this, I think this is coming up with the values here and exact value for the ranges is, I think, slightly challenging here just because of the length of it. But other than that, is a quite straightforward problem. It is rightly classified as medium as per me. So I hope you understood this problem. I see you in the next video. Thank you.